Ladies and gentlemen, as you could just see, we have quite the offer when it comes to hydrogen buses. But when it comes to the nitty-gritty, I actually wanted to talk to Paweł Mańkowski, who is the hydrogen technology development leader. Well, that's not exactly the name. I should just say that you're the leader of hydrogen technologies. Good to have you, Paweł.
Thank you. It's nice to be here with you.
It is great because I see some passion in your eyes. I feel like you really believe in the work that you're doing.
Well, I think that we have to always believe in the work that we are doing, and I think I'm the person for that.
You are, because fuel cells, you really believe that there is going to be a big change. Well, actually, when we've been preparing for that, you just told me that a lot has changed in the last 2 or 3 years, right?
Exactly, and the things that have changed, they have very big impact today on our production, on our buses, and I would say around the world, everywhere.
So what happened in the last 2 or 3 years? Is it the mentality of people that changed, or is it technology that improved?
Well, I think that both things you have already mentioned, they have their great impact on that, and the mentality is the most important thing, because a few years ago when I was discussing different topics with our customers, it wasn't so easy to describe them what is hydrogen about. And today, when we have a discussion with them, it looks like everybody knows about it very well, and they just want to have some more details about it.
I'm glad to hear that. Well, probably there are still some people who are skeptical because they think that the range will not be as big, or maybe that just caring for that or maintaining that technology will be hard. But you probably have some good news for them.
Well, I hope so, and I will try to show them to you.
And that's what's going to happen, so good luck with that.
I don't know what you think about that, but from my point of view, hydrogen is quite a catch these days. Each time we start a discussion about zero-emission mobility, we often hear about the fuel cells and the hydrogen, that the hydrogen is the fuel of tomorrow. But is it really a new concept? Is it something that was discovered 5 or 10 years ago? Well, to know something more about that, we have to dig a little bit of history. And when I think about the history, I mean we have to move back to the past. And I'm not thinking about 20 or 40 years. I'm thinking here about 200 years. We have to move back to 1840s, when a decent fellow called William Grove was working on so-called gas voltaic batteries. He has figured out in one of his experiments that during the test, when he was using hydrogen, oxygen, platinum foil, and a kit, he has created electricity from the gas, which was a really brilliant idea those days. But unfortunately, those days weren't made for the fuel cell. It was 19th century, and it was an era of combustion engine. So this idea had to wait a little bit, and it went over 100 years when Francis Thomas Bacon, who has figured also about this idea, has developed that. And because of his job, the fuel cell became more robust and more possible to use in standard applications. But it's not the end. NASA, as you have probably heard about this company, took over his patents in 1960s, and they have thought that they will use that in the space. And what often happens in the real life, if something is space certified, it can be also used on the ground. So after that, there was a short period on 1990s and beginning of the 21st century where the miniaturization of the fuel cell and robustness happened. Also, there was a very great impact put on the hydrogen cylinders. So today, they are much smaller and they can carry much more hydrogen. By the way, do you know that James Bond was driving a fuel cell car in 2008? And it wasn't an Aston Martin. Google that. Well, from this point of view, we know something about the fuel cell. But what about the hydrogen? Why the hydrogen is so attractive as a fuel? Well, to think about the hydrogen, we have to think about different fuels. For example, when you think about diesel, you have to remember that the power density in diesel is about 44 megajoules. But when you compare a kilogram of hydrogen to this kilogram of diesel, you have to know that in this kilogram you have 120 megajoules. So you can see those hydrogen's kilograms and diesel's kilogram are not the same. Also, when you think about those values from a different point of view, you have to state that in 1 kilogram of diesel you have 12.2 kilowatt hours, but in 1 kilogram of hydrogen it's 33.3 kilowatt hours, sorry for that. Well, this is one point of view when we think about the fuel, but the most important fact about the hydrogen is that is everywhere, it's infinite. And the only thing is, what we have to think about in next years is the way of taking the hydrogen from different things. And the best option would be to make it in the zero emission way. So, when we think about producing hydrogen, we have to remember that there are different ways of production. Next person who will be here in front of you after me, he will tell you a little bit more about that. But please remember that from the vehicle point of view, hydrogen has one color and is transparent, because we have to remember that having hydrogen on the fuel cell bus has a very big advantage, which is that there is zero emission at the point of the operation. Okay, well, we have discussed a little bit about the history of the fuel cell. We have discussed a little bit about the hydrogen, but now we should focus on what happens inside the fuel cell, inside this small magic box. So, if you think about the fuel cell, it's not only a fuel cell, it's a fuel cell assembly. Inside, you have fuel cell group in the stacks, but also you have BOP, which stands for balance of plant. And these are the components which are responsible for the fuel cell to work. So, on one hand, you've got a part of the hydrogen system, which is made often of HRB, which is the hydrogen recirculation blower, which is needed for transferring the hydrogen from the cylinders to the stacks. The other thing is that for the whole operation, you also need air preparation system, which is responsible for covering the air to the fuel cell. And because of the chemical reaction which is happening inside the fuel cell, you also need cooling components for that. From our point of view, when we think about our fuel cell assembly on the bus, you have part of the cooling system, which is the pumps and different valves. So, when you think about the fuel cell and the fuel cell assembly, please remember that all those components might be inside one place. And if you think about this box and the volume of it, please remember that this box which is making this power is almost or even a little bit smaller than the volume of a standard diesel engine, which is very important for assembly on a bus. But when you think about the bus, we've got different other components also when we think about the components which are used for making the bus moving. From our point of view, you have fuel cell, and with the fuel cell you have to take the hydrogen tanks. At this moment on our bus, we are using the newest technology, which is the Type 4 hydrogen tanks. Except that, to cover the heat which is generated by the fuel cell, you have to use a cooling radiator for that. So this is another part which is made also on our bus, which is assembled on the roof. Next things, when you make the power from the fuel cell, you have to handle the power, handle the electricity. So we are using a DC-DC converter to change the voltage of the power generated from the fuel cell to the voltage which is used on the bus. And for that, we have a traction container, which is responsible for changing the direction of the flow of the electricity, depending on the needs. This electricity may be sent to the batteries for recharging, but also can be sent directly to the axle, which is responsible for the driving of the bus. And this is the most important fact when we think about our bus, because this is not a classic range extender hydrogen bus. It's a real fuel cell driven bus. Except those components, when we think about all the other main components assembled on the bus, we have to remember about our air conditioning. On our hydrogen bus, we only use CO2 air conditioning with a heat pump, which means that they are working on the CO2 refrigerant, which is the least, let's say, harmful to the environment when we think today. So it has the global warming potential of 1. When comparing to other refrigerants, is the smallest number ever. Except that, we also have a Solaris high-powered traction battery, which is responsible for taking the power and giving it to the drive system. So this is the information about the components which are there on the bus. But what really happens during the driving, and what is the energy flow on the bus like? So at the beginning, you have to deliver the hydrogen and the oxygen to the fuel cell. In next step, inside the fuel cell, the electric power and heat, water, steam, is a combination of those three aspects, is generated as a result of a chemical reaction. And the generated electricity, like I said, is going to be sent to the DC-DC converter and then to the traction container, and depending on the needs, to different components. And because of that, our bus is moving without any signs of emission. And this is general overview of the bus. But when we focus really on the fuel cell, we can explain in a very short way how it works. So, as we have been saying before, at the beginning, the hydrogen and the oxygen is transferred to the fuel cell. The hydrogen reaches the catalyst and splits into protons and neutrons. And because we are using a PEM fuel cell, which stands for proton exchange membrane fuel cell, which lets through the protons to permeate to the other side. And the electrons are being captured and sent to an external circuit, where the circuit leads to our bus and to the DC-DC converter. And the protons of the hydrogen, which goes to the other side, to the catalyst on the cathode side, they then contact with the oxygen and create water and heat. And this is how the fuel cell mainly works. So, as we have been saying before, on one side you have clean hydrogen and clean oxygen, and at the exhaust side we just have a little bit of water and that's it. And this is the way the fuel cell is working today. And depending on different suppliers of the fuel cell may have different parameters, and also it's because you have different needs. In our bus, we are using a fuel cell with power of 70 kilowatts. The efficiency of the fuel cell is very high, and it might be up to 57%, and this is not all, because the estimated lifetime of a fuel cell is over 30,000 working hours. Of course, except that the fuel cell has different advantages. The one which we are using now, this is the 7th generation of the fuel cells from our suppliers, so they have really spent plenty of time working on it. So what we can say today also is that the fuel cell might be stored in very low temperatures. It can be stored down to minus 40 degrees. And when you are operating the bus, it can be operated from minus 25 degrees up. And this is very important because previous fuel cells, they used to be power supplied before taking off with the bus, which means if you wanted to drive, you had to connect to an external power supply or make something different to heat a little bit inside the fuel cell. Today, our bus doesn't have to have any operation like this. It's just working as you want to from minus 25 degrees up. Another important thing when we think about the fuel cell, this is the coolant of the temperature inside. It's also, let's say, much more closer to the coolant temperature which you have today in the diesel engine. So taking heat from this coolant is much more easier than it was before. And the coolant temperature range is between 60 and 80 degrees inside the fuel cell. And this is one thing, the fuel cell. But in our world, which we have today, there are different manufacturers of the fuel cell. And depending on the customer, depending on the manufacturer, there are different reasons and different, let's say, options to make it in the way the customer wants it to have. But this is not the best solution. That's why we are joining today STASH, which stands for Standard Size Heavy Duty Fuel Cell. And we would like to finish this program together and have a very good product in the end. Because think about this, as for our example. Please imagine you have a kid and this kid gets a toy. So you take this toy and it looks like, oh no, it needs some batteries. So you go to the shop, ask the clerk at the shop, I don't know, please give me 2 batteries, 55 millimeter length, 22 wide, with connection of SIA J279. And he goes to the back, comes back in half an hour and says, sorry, we haven't got those. And this is just an imagination, because today you go to the shop and you buy an AA battery. And imagine now, if it was the same with the fuel cell, that if you want to use a fuel cell of type AA, you put it on the bus, you connect it, and it works. And you can have from different manufacturers. And in the end, the market is so big, there are so many AA-sized fuel cells that you can make more of them, more buses, more different applications. And this is the reason why we are in Stash. And this is the reason why we think that the Stash will succeed. But we have described fuel cells, buses, different projects. But one more thing that we should remember, this is the hydrogen which is going to be sent to the bus, because you have to refill the bus. So, from our point of view, on Solaris buses, you have a nozzle which is capable of having a very high flow. And this high flow can be from up to 120 grams per minute. But as it usually happens, when you put something inside the cylinders and you compress those elements of hydrogen, they heat up. They heat up, and you have to also remember about the temperature of the hydrogen inside the bus. It cannot exceed 85 degrees. So, to have a better performance during the refueling, we also recommend to have some kind of a chilled hydrogen on the hydrogen refueling station. Because of that, you may have all the advantages of the high flow, which having 120 grams per second, and the capacity which we have today at 37.5 kilograms on the bus. If you make a short calculation, it can let you know that you can refill the bus in less than 6 minutes. But the 6 minutes can be made with a pre-cooled hydrogen. But this is another side of it. The other thing is that if you refill the bus, as we have been saying, you know that the flow is going to the cylinder, and then it heats up a little bit. It's always good to let the hydrogen refilling station know about that. That's why we have the communication between the bus and the refueling station. And it lets the hydrogen refilling station know about the temperature of the hydrogen in the bus, about the flow of the hydrogen to the bus, and about amount of the hydrogen which is already in the cylinders. And because of that, because of this communication, you can refill faster, better, and more efficient. And from our point of view, at Solaris, we are always having this option on our bus, and we have had that option from 2014 when we have made the first buses. So, to sum up our solution, from our point of view, when we think about our bus, we use the newest technology when it comes to the hydrogen tanks. So we have Type 4 hydrogen cylinders. The other thing is that we are using the exact amount of the power of the fuel cell that we need, and this is the 70 kilowatt of the fuel cell. And that, added with Solaris high-powered traction battery, which is capable of having very fast discharging and charging process, can give you a very good bus with a total range of about 350 kilometers depending on the circumstances, on the environment. And you can carry with this bus up to 89 passengers with 37 people seated. When you compare this kind of buses later between electric and hydrogen, for example, you can see what is the difference here about the passengers. So, what is important on the Solaris Urbino 12-meter hydrogen bus? That you have the exceeded range, you have a very fast refueling, you can have the reduction of the energy because of the CO2 air conditioning and other components, and altogether it is made in an efficient-free drive mode. So, this is the reason why we have made this product, and this is the reason why we think that the hydrogen is part of the future. And from our point of view, when we think about that, we don't want to stop here. I don't know if you have heard before, but we are going to make another type of the hydrogen bus. Next year will be the year of the 18-meter Solaris articulated hydrogen bus. And it will be the first bus with something I cannot tell you now because it's still a secret, but stay tuned and let us meet together in new zero-emission future next year. See you soon.